Chemical reactions. Burning of magnesium in air. We will require a small piece of magnesium ribbon, sandpaper, tongs, china dish, red litmus paper and Bunsen burner. Take the magnesium ribbon and rub it with the sandpaper so it looks silvery white. Hold the magnesium ribbon with a pair of tongs. Light the magnesium ribbon. It burns brilliantly and a white ash is left behind. Collect the ash of the burnt ribbon in a china dish and label it as magnesium oxide. Magnesium burns in air to form magnesium oxide, MgO. Take a little amount of magnesium oxide using a spatula. Place this on a moist red litmus paper that is placed over a white tile. The red litmus paper turns blue, indicating MgO is basic in nature. Heating of hydrated copper sulphate. We require hydrated copper sulphate crystals, distilled water, spatula, test tube holder, boiling tube and a Bunsen burner. Hold the boiling tube with the test tube holder. Using a spatula, take a small quantity of hydrated copper sulphate crystals from the watch glass and put it into the boiling tube. Heat the boiling tube over the flame of the burner, first gently and then strongly. On heating, copper sulphate crystals change its color from blue to white and water droplets are left on the walls of the boiling tube. Hydrated copper sulphate contains water of crystallization, CuSO4, 5H2O. On heating, copper sulphate crystals lose its water molecules and form white-colored anhydrous copper sulphate, CuSO4. Remove the boiling tube from the flame and cool it for some time. Using a dropper, take a small quantity of distilled water. Add 2 to 3 drops of water into the boiling tube containing the sample anhydrous copper sulphate obtained after heating. The white copper sulphate turns blue, indicating that the blue-colored hydrated copper sulphate is regenerated. So this reaction is a reversible chemical change. Reaction of iron nail with an aqueous solution of copper sulphate. We will require copper sulphate, iron nails, distilled water, a beaker, measuring jar, test tubes, 2 clamp stands, a piece of thread and a glass rod. Take sufficient quantity of distilled water in a measuring jar and pour it into a clean beaker. To this, add a required quantity of copper sulphate. Stir the contents in the beaker using a glass rod until the copper sulphate crystals in the beaker dissolve completely. Pour sufficient quantity of copper sulphate into a test tube. Clamp the test tube to a stand. Then pour sufficient quantity of copper sulphate into another test tube. Clamp this test tube to another stand. Take 2 iron nails. Clean these by rubbing them with a sandpaper so their color appears grayish. Tie 1 nail with a thread. Immerse this into one of the test tubes containing copper sulphate solution. Keep the 2 test tubes undisturbed for about 15 minutes. After 15 minutes, the color of copper sulphate solution containing the iron nail turns light greenish color, whereas the color of the solution in the other test tube does not change. The greenish color of this solution is due to the presence of Fe2 plus ions. Remove the iron nail from the solution. Compare it with the other nail. There is a brown coating of copper on the nail that was dipped in the copper sulphate solution. The other nail retains its grayish color. Reaction between an aqueous solution of sodium sulphate with barium chloride. We'll require sodium sulphate, barium chloride, dilute HCl, a beaker, conical flask and test tubes. Take a small quantity of barium chloride in a test tube and transfer it into a conical flask. In another test tube, take a small quantity of sodium sulphate and transfer it into the conical flask containing barium chloride solution. A white precipitate of barium sulphate is formed immediately. This confirms the presence of sulphate SO4 2- ions. Stir the contents of the conical flask and keep it undisturbed for some time. The precipitate of barium sulphate settles down. Decant the upper solution from the conical flask into a beaker. Then add a small quantity of dilute HCl into the conical flask containing the precipitate. Swirl the flask well. The white precipitate is insoluble in dilute HCl. In this chemical reaction, sulphate ions are displaced by chloride ions and chloride ions are displaced by sulphate ions. Reaction of zinc with dilute sulfuric acid. We require zinc granules, dilute sulfuric acid, NaOH, test tubes, conical flask, Kip's apparatus, cork and glass tube. Using a spatula, take some zinc granules and transfer this into the conical flask containing dilute sulfuric acid. Bubbles of hydrogen gas are evolved as zinc granules react with dilute sulfuric acid. Show a wet red litmus paper over the mouth of the conical flask. There is no change in the color of the red litmus paper. Then show a wet blue litmus paper over the mouth of the conical flask. There is no change in the color of the blue litmus paper. This indicates that hydrogen gas is neither acidic nor basic. Now, cork the conical flask with a single bored cork. Introduce a fine jet tube through the hole in the cork. Bring a burning candle near the mouth of the fine jet tube. On bringing the flame, the gas coming out of the jet tube burns instantaneously with a small explosion, produces a popping sound and then dips out. Now, pour about 2 ml of the solution from the conical flask into a clean test tube. Then add a few drops of NaOH solution to the test tube. A white gelatinous precipitate is formed. Shake the test tube well. Then add NaOH in excess to the test tube. The white precipitate is dissolved when NaOH is added in excess. The precipitate formed is ZnOH2. This indicates the presence of Zn2+ ions in solution. Place the test tube in a test tube rack. Then pour about 2 ml of the solution from the conical flask into another test tube. Pass hydrogen sulfide gas through the solution in the test tube using Kip's apparatus. Shake the test tube. A white precipitate of zinc sulfide is formed. From this reaction, we can infer that zinc is more reactive than hydrogen, so it displaces hydrogen from dilute acids and passes into the solution as Zn2+ ions.